Hey guys, it's Mr. Marone again. Welcome back. We are going to do measuring angles today. So it's going to be very similar to what we saw with measuring segments, only we're going to be introducing a new geometric figure that we'll use throughout the year. So the definition of an angle, it's two rays that share the same endpoint, but they're not opposite rays. We will have one that is an opposite ray later on, but they're going to be in all different shapes, but they're not going to be just opposite rays that we've seen so far. The rays are the sides of the angle, and the endpoint is the vertex. So as you see in the diagram on the right there, ray AB and ray AC are the two sides of the angle, and the vertex is actually going to be point A. So we can circle that right here. So point A is our vertex, and AB and AC are going to be our rays. And it's going to be named in three different ways. So we can name it by the vertex. We can put a small angle symbol and make it angle A. We could also name it by using the point on each ray with the vertex and making sure that the vertex is in the middle. So I can call this angle BAC. Or you can use a number that they place on the inside that will not have a little symbol up here to tell us what the measure is. So we can refer to this as angle 1. Okay, so three different options, and you can use any one of them, and they'll all be used interchangeably throughout the year. So just be comfortable with all three of those methods. Okay, so a couple other pieces of angle information. When you're naming an angle using three letters, the middle letter has to be the vertex. That's going to be a key indicator into where an angle or how we're going to read angles. So the middle letter has to be the vertex. And then when we look at an angle, any of the space between the two rays is going to be considered the interior of the angle, and all the space outside of the rays is considered the exterior of the angle. So if you see in the picture on the right, the interior is between those two rays on the right hand side, and the exterior is all of the stuff on the outside of the angle. So when we name an angle, it says using the angle on the right, give two other names for angle 1. So we have angle 1 right here. Okay? And if you look, we've got a ray MJ and a ray MK that are forming this angle. And when we name this, we can name it by the vertex. So we can just call it angle M. The other way that we can name this angle is by using the two rays with the vertex, as long as we name the vertex in the middle. So we can name this angle JMK. And just as we said with segments, these are commutative. So if you wanted to name it angle KMJ instead, that's fine as well. Second question says, would it be correct to name an angle M simply? So as you see above, that's what we had listed, but is that actually a correct name? The issue is that angle M, or this vertex M, is shared by two angles. So when we say angle M, we're really not specifying. So angle M is not a name that we can use, so we would have to use angle KMJ here, okay, as our second angle. So you cannot use a vertex to name, or a single letter to name an angle, if it's shared by two different angles. So just be aware of that as you're looking and moving forward. So just like we had the ruler postulate and how we felt it was kind of a silly thing to have to state, we have the protractor postulate with angles. We measure in angles using degrees, and we use a lowercase m to indicate that we're discussing a measure rather than simply discussing an angle. And the protractor postulate says we can measure angles, just like the ruler postulate says that we can have measures for segments, and we measure everything from between 0 and 180 degrees, as you can see on that protractor here. We start down at 0, so you're going to start down here. You're actually going to work your way up along the protractor to notice that the measure of angle, the measure of angle AOB equals 125 degrees. Okay? And just remember, just like with the ruler postulate, you cannot have a negative angle measure in geometry. So we don't ever expect to find negative 125 degrees. Everything will be positive, and if you wanted to use absolute value symbols, you could there. So we have four types of angles that I'm sure you're familiar with from your time in other math classes. We have acute angles from 0 to 90 degrees. 90 is not included in that. That's why we have just a less than symbol. So we need to keep in mind that anything less than 90 would be an acute angle. A right angle is exactly 90, and really make sure that you have one of those right angle markers. This is one of those common areas that people mess up, assuming it's a right angle when there's no marker there. Obtuse is anything bigger than 90 and less than 180 degrees. And a straight angle, this is the opposite rays that I talked about earlier, will always be 180 degrees. So you have two that are standard at one measure, and then you have two that are varying depending on how big or how small the angles are. So if we look closely at this, they want the measures of L, K, N. So L starts here, down to K, and over to N. We can start at 0 and work our way all the way up, and we learn that this is angle LKN is equal to 145 degrees, which would make that obtuse. Angle JKL, starting here, working our way down and over, we started at 90 degrees and we worked our way all the way over to 145 degrees. So we go 145 minus 90, and that's going to give me an angle measure of 55 degrees, which is acute. And our final angle, angle JKN, is going to be from straight down and over, that's going to be 90 degrees, which is a right angle. Okay, and just like we had with segments, congruence is when two angles have the same measure. They can be classified as congruent. We mark congruent angles with arcs in the corner of an angle rather than tick marks on a line. As you see in that image there, angle A and angle B have the same measure, so therefore we can say that angle A is congruent to angle B. And the final piece that we have that's once again similar to our segment section is we have the angle addition postulate. It says that if I have two angles that share a side, and if that point B is in the interior of that larger angle AOC, that the two pieces can be added together to create the whole angle here. And let's take a look at an example of it. So here they tell us that angle RQT is 155 degrees. This outside angle here, this is a Q. And in order to find that out, we have to do angle RQS plus angle SQT. And that together is going to equal angle RQT. So setting this up, angle RQS is 4x minus 20. Angle SQT is 3x plus 14. And they told us that RQT was 155 degrees. Combining like terms on the left-hand side, we have 7x minus 6 equals 155 degrees. I'm going to add 6 to both sides. So we have 7x equals 161 degrees. And dividing both sides by 7 gets x equals 23. And once again, remember, up here they asked for the measures of RQS and TQS, so we have to plug back in. So RQS is going to equal 4 times 23 minus 20, which is going to give me 92 minus 20, which is going to give me 72 degrees. And if we do 155 minus 72, it's going to give me 3, and 15 minus 7 is 8. That's going to tell me that angle RQT equals 83 degrees. There's RQT, and there's angle RQS. If you have any questions, feel free to ask or send an email, and I'm going to leave you with a problem to try that we'll go over in class tomorrow. So they gave you that angle DEF is a straight angle, and they want angles DEC and CEF. Good luck.